Welcome back to eCoreAcademy, everyone. My name is Anita Raj, and I am one of the co-founders here, along with my younger brother, AJ Raj. Today, we're going to be continuing our probability unit, but as you know, this is a probability and statistics unit. This video was requested, and it's called Finding Standard Deviation. Deviation falls under statistics, and we're going to learn more about what measures of variation are, also learn about what standard deviation is. We'll look at a set procedure of about 4 to 5 steps that we will take in order to calculate standard deviation. Specifically, we'll be looking at mathematical notation. This mathematical notation would apply to if you were doing it by hand, which is pretty tedious, and if you were doing it on the TI calculator, and then we'll dive into how do we utilize our TI calculators to have the calculator compute standard deviation for us. So before I get into this video, I just want to show you what this graph is. This is called a bell curve, and this is like the standard deviation curve. So standard deviation, when you actually graph it on a curve like this, a bell curve, you'll see that the middle is the highest. These points, however high they are, represent how much of a set or how much of a population fall in that range. Let's say we were measuring the weights of female bears out in the wild. That was an example I saw quite a lot when I was taking this Algebra 2 course in my school. You have an average or a medium or what's considered like a normal weight for example, a female bear. That would fall in the middle, so that would be right here. And usually when you have a population or a set of individuals and you determine what the average is, most of the individuals are going to fall around average, because average means normal. Average encompasses most of the people. Then when you go to the right or towards the right extreme, you'll see that the amount of individuals who fall into these categories start to decrease. So like the example I was talking about with the female bears, if this was the average weight and we started going to the right, we're kind of considering females with a very, very high weight. And if we go to the left, we're considering females with a very, very low weight. And there are going to be less individuals in those extreme categories. That's just how it occurs in nature if you took biology. So that's pretty much what a bell curve represents. And a bell curve, again, has to do with standard deviation. All right, so before I get into this video, I would really appreciate it if you could like, subscribe, hit the post notification bell, and drop a comment down below. All right, so let's get right into the first slide. Let's define some words and use this because I'm going to be using these terms and your teacher will be using these terms. So here's some vocabulary for you. The first is measures of variation. So measures of variation are used to describe how the data in a set are spread out. Variation, let's define that word first. It's a change or a difference in a condition, in a level, in an amount, and typically this will come with some kind of limit. Or you can think of it as a different or distinct version of something. So you can think of it as a difference. Something is changing, something is not constant. If we talk about measures of variation, you can think of them as the width of a distribution. So what's distribution? Well, a distribution you can think of like a warehouse. When we distribute products, we're sending them off in different directions. They're going their separate ways. Distribution is how spread out or separate the data is. So a measure of variation is going to be defining how spread out the values are in a data set. You could also call this like a measure of dispersion or a measure of spread. The next word that we're going to be defining is standard deviation, which is the name of this whole lesson. Standard deviation is a measure of how each value in a set varies or deviates from the mean. Again, we said that the mean was the average or middle value, so you can think of it as the most recurring value. Actually, no, that's the wrong word. That's the mode. The mean, you can think about, the best way I can put it is, again, the average are what is considered normal in a group, and then every value in a data set might not be exactly equal to the mean. So a standard deviation is supposed to calculate how far are these values that are actually in the data set we're analyzing from the mean that we calculated from the data set. So in other words, it's a quantity calculated to the extent of the deviation of the group. So however the group deviates or spread out, that's what a standard deviation calculation is. And when we represent standard deviation, we are going to represent it by the Greek letter sigma, and that's the symbol for sigma. You're going to see that come up, so I just want you to be familiar with it. Instead of writing out standard deviation of this set is equal to whatever number, we're just going to write sigma x. You'll see that notation later on is equal to whatever the standard deviation is. All right, so here's a procedure that we're going to use to actually calculate standard deviation. I actually copied this right from my textbook because I thought they did a great job explaining it, and you can see I actually wrote annotations on it. So let's walk through this pretty fast. First, you're going to find the mean of the data set, and it's going to be represented as an x with a little bar above the x, and we call this x bar. So you can call this notation, this symbol, the mean, or you can call it x bar, whatever you want, same thing. But when you see this x with a bar above it, it means we're talking about the mean of a data set, or the average. The average we find by adding all the values in a data set together and then dividing by the number of values. Afterwards, we're going to find the difference between each value and the mean. So after we find the mean, what we're going to do is we are going to take each value in the data set and then subtract x bar, or the mean, from it. So let's say our data set is 9, 8, and 10. So the average of that is going to be 9, and what we're going to be doing is we're going to be subtracting 9 from 8, from 9, and from 10. So we're going to subtract the mean from every value in the data set. So the value minus the mean. After we find every difference, we're going to then square each difference. So like I said in this example, 8, 9, and 10, 8 minus 9 is -1. We're going to square that and get 1. 9 minus 9 is 0, square that, get 0. 10 minus 9 is 1, square that, and get 1. The reason we're squaring it is also, you'll see this in the chi-square test in biology. It's because we don't want really any negative numbers. So usually you'll see that we'll square values in math so that we don't get negative numbers, because when you square any number, a positive or a negative number, you're going to get a positive number. Afterwards, we're going to find the average, or the mean, of these squares. So what we're going to do is, you'll see the symbol, it looks like an E. It's actually the symbol for summation. As you can see here, sum of all the squared numbers. So we're going to take all those squared numbers that we found, all those squared numbers we found in the previous step, we're going to add them all together. And again, I just want to go over this E. It's called the symbol. It's a symbol of summation. It's just a shorthand notation. If we're going to sum up all the terms in that follow a pattern or in a sequence, instead of writing every single term out, we can just write this E, and it represents summation. So we're going to add all of those squares together, and then we're going to divide by the number of squares, or the total amount of numbers. And then afterwards, to finish it off, we're going to take the square root of the summation divided by the total number of numbers in the data set. So the average, we're going to actually square root the average, and we'll use that to find the standard deviation. And as you can see, that sigma has appeared again, that Greek letter we looked at on the last slide, that represents the standard deviation, or sigma, is equal to this notation that we just covered. All right, so now let's talk about standard deviation on the TI calculator specifically. The first step you're going to take is, I'm actually going to pull out my TI calculator now, but the first step you're going to take is obviously turn the calculator on. Then you're going to go to the stat feature. Again, I'll be showing you all of this when I'm actually going to switch webcams so that you can see my calculator, because we'll do 2 practice problems. You go to the stat button, and then you're going to enter the data in L1. So you're going to go to the stat button first. You'll come to a menu that says Edit, Calc, and Tests at the very top, and then you're going to stay on the Edit menu, and you're going to already be on one that says Edit. You're just going to hit Enter, and then you're going to have columns L1, L2, L3 that are going to be empty if you cleared out your calculator, and then you're going to enter whatever data set points you've been given into L1. So each data point will go in its own little box. Step 2, after you enter all your data points, you're going to hit Stat again, and then you're going to hit the right arrow so you can go over to the Calc menu in Stat instead of staying on Edit, and then you're going to choose one variable Stats, which is option number 1. One variable just has to do with L1. That means we only enter data points in one column. That's why we're working with one variable Stats and not 2 variable or anything else. So it's already going to be highlighting number 1, which is one variable Stats, so you can just hit Enter, and then you can just scroll down past frequency list and all the way to calculate, and then you can just hit Enter, and then you'll be given like a whole set of different statistical calculations, and from that set this is where the symbols come in handy. You have to be able to determine which symbol represents the mean, and that's going to be x bar. So the mean is given as x bar. It's actually going to be the first on the list, and then you're going to have to look down a bit, and the standard deviation is given as sigma plus an x next to it. So it's going to be given as sigma x. Standard deviation and mean are not going to be completely written out on the menu. They're going to be done in shorthand with these symbols, so make sure you're looking out for these symbols. All right, so we're going to be diving into practice problems, so let me switch my webcam view so you can see my TI calculator and we can get to this. Alright, so I switched to webcams, and now I'm back with a view of my TI-84 calculator. We're going to just be walking through a standard deviation, and this is going to be example number 1. Just given raw data points, not even any kind of real-life situation. Just going to be testing our ability to use the TI calculator, first of all, and second, to be able to interpret symbols that represent standard deviation and the mean. So let's get right into the problem. The problem is we're being asked to find the mean and standard deviation of this given data set using this TI calculator. Here's the data set. We have 8 points, 50, 60, 70, 80, 80 again, 90, 100, and 110. So we're going to use these data points and we're going to find the standard deviation and the mean using the TI calculator. So our first step, well, hopefully you already cleared the calculator, but second, mem 712. And then that should have cleared your RAM. You can just hit clear again, and what we're going to do is we're going to go hit the stat button. It's right here underneath the delete button. So you're going to hit the stat button. Then we are first going to go to number 1, which is edit. So you can just hit enter, and then in our L1 column, first we're going to make sure it's clear. It is clear. We're just going to enter all the data points we've been given. So 50, hit the down arrow, 60, the down out arrow, 70, hit the down arrow, 80, down arrow, 80 again, down arrow, 90, 100, 110. Now what we're going to do is we're going to hit the stat button again, and we're going to actually hit the right arrow so we can go over to the calc menu. And you see right now my cursor is on one variable stats, which is what we want, so we hit enter. We're on list, we have our list, L1 list, where we put all the data points in, so we're just going to scroll down to calculate. When our blinker is on calculate, we hit enter, and we're given all these stats. So how do we interpret them? First, we got to figure out what the mean is. The mean is x bar, and it's the first up here. The mean is equal to 80, so the answer to the mean question is 80. How about standard deviation? Well, let's look down all these values, and we see sigma x. That is what represents standard deviation, and you can see it's about 18.708. So we can round that to 18.7, and that's pretty much how you'd find the mean and standard deviation using a calculator. Pretty straightforward. Moving on. Let's look at another standard deviation example, but this time it's more realistic. We have 12 men, and they all qualified for the 2002 U.S. men's alpine ski team. We're going to find the mean and the standard deviation of their ages at the time when they qualified. So when they qualified, their ages were all recorded when they qualified for this team, and we're going to be given those ages, and we're trying to find the mean and the standard deviation of their ages. So the ages are the data points in this set. Here are all the ages. There are 12 of them, and we're going to input them in the calculator and find out what the mean and the standard deviation are. So I'm going to hit stat again. I'm going to be on edit this time. I want to edit my L1, so I go in, and here's my data table. I'm actually going to scroll up, so my cursor is on L1, and I'm going to hit clear. And what that will do when I scroll back down is it'll clear this whole column. Now I'm just going to go about entering all the data we've been given, 27, 28, 29, just reading it off the screen, 23, 25, 26, and there's another 26, so make sure you keep that in mind and not make a mistake, 28, 22, 23, 21, and 25. When you were younger and you did basic mean, median, mode calculations in math class, you did them all usually by hand, and what your teacher would tell you to do is when you're given a data set, especially a kind of long one, is to order all the numbers from least to greatest, which you can do, but since we're using the TI calculator, we don't need to waste time doing that because we don't need to order our data points from least to greatest, so just keep that in mind. You don't need to waste time on an assessment. If you're allowed to use a TI calculator, you can just throw them in. You don't have to order them and put from least to greatest in order in this data column. Alright, so now we're going to hit stat because we want to calculate. We're going to hit right to go to the calc menu. We're already on one variable stat, so we're going to hit enter. And we're going to scroll down to calculate, hit enter again. We're given the mean x bar. Remember, make sure you can interpret those symbols. X bar represents the mean. It's 25.25, which is the answer to that question. Then if we look down a few rows, we see sigma x, which is going to be the standard deviation, which is equal to about 2.45 if we round it to the nearest thousandth. And that's how we solve that problem using the TI calculator. Well, I hope you enjoyed that pretty brief video. It's just introducing you to finding standard deviation. In the next video, we'll discuss more about how do we interpret values we find from calculating standard deviation, and then I'll consider doing a third problem on some practice problems. I actually do think that will be very important, so I'll add that in there so we can work through some together. I hope you enjoyed this video, and if you did, please like, subscribe, hit the post notification bell, and drop a comment down below. Check out our website and Gmail while you're at it, and I'll see you in the next standard deviation algebra 2 video. Bye!